Hello and one welcome back. Today on the bench is the Stearns Stereophonic preamplifier, and in the last thrilling episode we had two valves that were showing adverse DC conditions. Squeak! I have it powered up, etc. This is one of the valves that was playing silly buggers. Haha! So we're reading 2.7 there where we read 0 before. So all I did previously to turning you on and all the rest of it, ho ho ho, is swap the valves, and I also jiggled the valve in the valve base a bit. So I'll just carefully try and do this without getting a belt. As you can see, I'm jiggling the valve in the base while monitoring the cathode. Remember me saying the cathode is the go-to. See, now we've got Sweet FA. Oh, you bugger! Uno momento, por favor. Right, where was we? We're jiggling this valve about. Right, what I'm going to do, instead of just mucking about with it, sort of ad hoc, and trying to fault find and diagnose, I'm going to go through, clean up the valve bases, and check all the resistor values to make sure that they are bang on. And similarly, try and see if we've got any leaky capacitors. Get that sorted out, and then we'll come back at the job, because I'm going at it a bit half-arse, but I'm also trying to make a video for your edification and education. So I've just been through all of the components, just using the resistance reading measurement thingy on my digital multimeter. As predicted, all these high stability ones, as far as I can tell, measuring them in circuit, are fine. I thought they would be. They're very good quality components. They're probably made by Payton, but somebody may say different. And as you can also, they're higher tolerance for a start. Some of the ones that I thought might be a bit off, or a little bit, like these airy ones, but they're only a very low, low tolerance, like, so they're not 1%. What are they? What's the silver? Is it about 25%, 20%, something like that? So yeah, worth checking. We'll see. But they're only doing like a dropping. All they're doing is dropping the voltage going into the valves, so yeah, not really worth, not sure whether it's worth changing those out. The other thing I did was just did a resistance reading across the capacitors that we can see here. Didn't get any anomalous readings. These ones here, these resistors, these 100Ks, you think, ooh, they look a bit crusty and crap, but that one measured okay. This one measured a bit high, but we'll have a look at that. So what I shall do now is just go through with and check the electrolytics, specifically with a ESR meter and a capacitance meter, and then we shall see what we shall see. Well, it helps if you press the bloody record bloody button, doesn't it? I've just been waffling on for the last 10 minutes, and obviously you haven't heard a damn thing because it wasn't recording. X-Ray Tony were going on about this the other day. Anyway, so far I've found that one measuring borderline ESR. Ooh, fucking horror. As you can see, that one measures good. Just put that up there. And that one measures good. So, what do we know so far? So basically all this here, what we see here, is essentially setting the DC conditions of the preamplifier. I'm gonna unsolder the ends of these and test them again. Might change them, I don't know. But I know I haven't got any axial electrolytics, I don't think. I think the axial electrolytics I've got are probably as old as these buggers, so I don't know. And like radial electrolytics, while they might, I don't know, it just don't look good. I want to try and preserve the, you know, the vintage of the thing. So I'll just unsolder them, have a little bit of a look. I might take these mica molds out. I think it'll probably benefit from that. When I've got all the DC conditions right, we'll stick some AC in, a signal in, and see what we shall see. I've applied fresh solder to all the joints on these electrolytic axial capacitors. 25 microfarads, 25 volts. And sucked the excess solder off afterwards, and looking at the construction, what the chap has done, I presume it's a chap, has bent the leads over. And I know from experience that if I can probably get them undone, but it will involve tugging and, yeah, damaging this tag board here. So essentially I've only got one option, and that is to cut it out. So before I do that, let's have a look at the capacitors that I've got, if I do take this out, that will replace it. First, I've got a selection here. I've got some modern radial 22U 50 volts, lots of those. I think these are Panasonic. Hold on, Memento. 105 degrees. I think the Panasonic. They're either Panasonic or Sony. Anyway, the good ones. However, they've been sitting there for probably 10-20 years. I've got these axials which look like Philips. Let me just have a look. 22U 63 volts axials. Got these Sprague 25U 25 volts, and I finally have this sort of motley collection of disparate 25 22U axials, and yeah, most of those look about fucked. However, in there I'm pretty sure are some wet tantalum ones. These ones, no, is it these ones? Yeah, these STC ones, 22 microfarads. Yeah, you can feel they're like really heavy. So we'll test a couple of them, and then we'll test the rest and see what the crack is. Right, hopefully you can see that. So first off, the modern Sony, Panasonic, whatever they are, 105 degrees parts. Sorry about this setup, I have to put it at a bit of a mad angle, because if I don't, you can't see it. Helps if you turn the damn thing on, doesn't it? So, oh damnations. Again, doing this round the camera is immense fun. So, good. Yeah, probably need a bit of reforming though. Let's just test the other one for completeness. The leads are a bit tarnished, so I'd have to clean them up. Yeah, about the same, good-ish. I haven't looked at the chart to see if that's the exact reading that we should get, but it's just a rough indication. STC, that one Test very good. Very good, sorry. As does that one. So far we're good. So I got the music on for the dog. I'm dog sitting today. We'll test a couple of these. Look like Philips. They could be Vichy, or the people who used to have Vichy before Vichy bought them out. What are they called? I can't remember. They test good here, so another one. Good again. I'm trying to get through this fast because this video is going to be long as it is. Right, I think these are the last ones to test. Yeah, sorry guys. These are the Sprague. Good. Just put that one there. Good. Right. Now let's swap the leads over and test the capacitance. Remembering to turn the ASR meter off. This is just a really old knackered 10 digital multimeter, which is I don't know, it cost me 70 quid, and I blew the arse out of it by putting HT in it when it was set to resistance. A fluke would just laugh at that, but this one, yeah. Anyway, it reads capacitance. This is the Panasonic Sony 24 mic. Usually when caps start getting old and a bit tired, they go high in capacitance. Takes a little bit of a time to make its mind up. 24, so okay, yeah. Right, which ones do we test next? These ones. The STC wet tants. Bang on. Oh no, hold on. No, I thought that said nano. 25, bang on. I think these STC ones are the mutts nuts, to be honest. I haven't checked to see. Oh, come on, don't squeak. 22. That is pretty good. These STC ones, like I say, I think the wet tants and the, yeah, pretty damn bang on, aren't they? Okay, 24. Actually, all these capacitors that I've tested so far are reading rather good. Lastly, oh damnation, I'm a crap video thingy-ographer. Okay, you see those? The Spragues, 33 they're reading. I use these Spragues actually in the big 50 watt amps that are about. Big 807 jobbers. Yeah, see? So they're reading high, which is an indication that they're probably a bit iffy, but after a bit of applied voltage to them, because electrolytics work a bit like a battery, well, a battery in reverse, they need a polarizing voltage across them to maintain their value, to function properly. So yeah, sticking a 63 volt capacitor in a circuit that is probably only going to see a couple of volts isn't ordinarily a problem, I don't think, but I have, or did I read somewhere or see a video or something where it said that they can develop a bit of, I don't know, higher distortion if they're not seeing that correct polarizing voltage. Whether that's the case or not, I don't know. It's something I've not really come across or measured when testing. Anyway, I'll have a think, but I think these STCs are the favourite to pop in as a replacement, whether they need it or not, because they look the same and they seem to be reading the best out of all of them so far. Like the complete arse that I am, I've broken the tag off this tag board. They are really thin. They're not very good quality tag boards, so caution, Will Robinson. And as an example of how good these resistors still are, so that's a 1K2, 1.2K, yeah, bang on, no need to replace those. Regarding the cap that I took out, as you can see, that's reading well high, 40 microfarads, and it was still testing out of circuit, horrible ESR, so definitely needed replacing. So I'm just going to replace all the rest of them with those STC ones after having tested the STC ones, because like if you're using new old stock parts, you need to test every single one before you use it. No good just like testing one, got to test a whole lot, otherwise you could just be saving up faults, sort of problems for yourself later. There we are, sometime later, getting these replacement capacitors in here as nicely sort of sighted and all the rest of it as the ones that the original builder did takes a lot of time. I spent ages trying to blinking desolder the damn tag board and everything. Oh, right, I thought I got that one in, but yeah, getting them to just sit really nicely is yeah, difficult, because I always try to position a component so you can see the value, so you know, obviously some person like sometime later can say, all right, that's a 22 microfarad capacitor. See, like what the chap has done here, 1 meg 220, makes the job easier for somebody who comes later. But yeah, getting them to sit there is difficult. So for instance, I've managed to unsolder this tag here so I can just poke the lead through, but in this case, if I was to solder it in there like it is, but it's not symmetrical, you see, it's not parallel, so it does take quite, oh yeah, a bit of mucking about to get it in there. And obviously we need to get it so it's in line with all the others. Right, well, we still that wants to be there. Right, I've bloody bent that one wrong. Sorry, you can't see, can you? Right, let's try putting a bit more of a broader thing in it. Right, let's try that. So we want to be up there. Right, so now hopefully you can see I need to bend that at 90 degrees so that it comes round here. Let's try it about there. So we want about that. A lot of this is just, you know, eye, you know, by eye. But this is the sort of effort I go to. You see, that's wrong. That is not parallel. Doesn't look it to me anyway. So this needs to come over here a bit, doesn't it? So that needs to. Sorry, you can't see, and I've got it zoomed in. Have less of a. Let's try that one. So just soldering in a capacitor, just so. Right, that looks about right. See, that's parallel, in line with all the rest of them. How's beard? Right, I'll just leave that there for now, and then what I'll do, I'll tack that one in. Will it stay? Or will it fuckers right? Let's just put a tack there. Right. Oh, and of course, like now, it doesn't want to sit properly, do you? Hell's beard. Right. Are we right there? Are we fuckers like? Oh, Jesus Christ. So, how long has this took me so far? Looking at the screen, about 5 minutes. And we're still not done yet. Right. Oh, hell's. Yeah, I keep uttering profanities. Oh, come on. Right, if I can just. Right. Are you gonna. No, of course you're not. See if we can get this in here. Obviously a lot harder around the camera. Right, so now I'm gonna. Right. Oh, fucking hell, come on. Right. I'm gonna do this without the camera in the way. Una memento, as I keep bleeding while saying. Right, as they say in cricket, I'm happy with that. Yeah, I haven't measured exactly the parallelousness, but yeah, I'm happy with that. All the other ones are in. Well, not all the other ones, I've just got one more to do, which is a bit snug against all this, but right, I shall crack on and see you a little while later. Another day, unfortunately no dollars as yet, and so as you can see I've got the 4 replacement capacitors popped in. Yes, I have got them round the right way, because that's the usual sort of clever shit that I do. Spend like 10 minutes or even like 20 minutes putting in a capacitor only to find it's the wrong way round and having to do it all over again. Didn't happen in this case, but each one of those capacitors must have taken about, well, it took me the whole freaking morning, so yeah. Anyway, we've got to maintain standards, haven't we? Come on, we're British, we make the finest. Well, I don't know about that. Anyway, I shall stop fucking waffling, and I'm swearing again. Oh well. Right, the other thing I did prior to doing the capacitors was to go around with a very, very small diameter drill and gently jiggle each pin to try and clean it up, because I think some of the adverse DC readings that we were getting on 2 of the valves may have been caused by that. And then the other thing I did was put a bit of IPA in and put the valve in and out sort of thing, you know, a word misses. And then I have these handy dandy little things, I've never seen them and I've no idea where they came from, to straighten all the pins, which I found is beneficial in the past. And the other thing I did on a few of the valves was to just, you know, little bit of very fine, like sort of 1000 grit wet and dry, just clean the pins up. On one EF86 I did find this odd anomaly which I haven't seen before, and I bet you can't see it. If I just turn the valve, what I'm looking at is this noggin here. Move it there. The glare from the, can you see that? If you just sort of look at this background here as I rotate the valve, you see this little nubbin there, and that's on there. That is on there, and I have no idea what it is. It looks like some sort of metallic thing. I don't know, never come across it before, and it's on there. I'm not going to try and remove it. So now I'll get to the point. Oh Jesus Christ, sorry, I must not take the Lord's name in vain, or whatever that means. So after doing all that, check the valves, the fit as it were, and I'm decidedly underwhelmed about their fit. Is the only way I can sort of describe it. I'll have to see if I can find some screening cans. I'm sure I've got some. Yeah, look at that one. I mean, that one is just held in there mainly by gravity. That one's better, but that one's absolutely shite. Oh, come on. And there's that one. See? I mean, yeah, puff of wind and that'll fall out. Or if the auntie like has too many broccoli sprouts like on a Christmas, yeah, and she lets rip like, woo, yeah, it could knock one channel out, and that one. So we've got basically 3 valve bases that are absolutely crap, or a crap fit, and I am not looking forward to having to replace those. So I'm going to see if I can get some screening cans, pop them on there, see if that improves the situation, connect it back up, fire it back up, and yeah, see if the DC conditions improve, because without those, without getting all that right, there's no point touching all this. Yeah, absolutely no point whatsoever. Right, I shall shut up and go and try and find some screening cans. Screening scan. Oh, for fuck's sake, I can't say it at this time in the morning. Screening can stash raided. Found 4. Found 4 that should do the job. Let's try that. And then, yeah, I really don't want to go there if it doesn't work. There be dragons and sea monsters. So, having tried using the cans to try and get the valve to see better, I'm pretty sure that the valve bases is the issue here. However, looking in my B9A valve stash, it is very depleted regarding valve bases, and I've basically got these 2 used ones which won't suffice. So this morning I went and had a look at the valve baser to see what sort of valve pin structure there was. I've told you in the past about the horseshoe type ones. These ones are a little different. Well, they are totally different from the tuning fork ones. Did I just call them horseshoes? Tuning fork ones, they have like a square, so it's like a cup but it's square sided. I'm hoping you'll be able to see if I zoom you in. Don't know if it's gonna focus. Let me see if I can point at it and that might focus it. Right, I don't know if you'll be able to see. I've tried to focus in closer. This pin here, which is pin number 1 I believe, if I get my orientation right, it's folded over. So let me zoom out again. So there's like a square cup, one side is folded over, so obviously the pin won't make good contact. And I've just been in with a really, well, it's the sharpest, thinnest screwdriver I've got, and I have managed to get the other ones to like fold in a bit. So so I'm going to go and try that and maybe have another go at trying to clean them up, because A, I don't want to have to change them, it's going to be an absolute fucking nightmare. B, I haven't got anything to replace them. And C, time, tick tock, tick tock. Here we are some time later, and I've been testing it again and trying to figure out why this valve here, V2 on V2, I'm not quite sure which channel it's on, isn't conducting properly, isn't working properly. Basically we're getting nothing on the cathode. We're getting nothing on the cathode. So what I did, I connected a voltmeter up to the valve as I was powering it up, and I watched the cathode voltage coming up and then it went down. At first I thought this could be down to this valve base being utterly crap. Basically it's old, very worn and tired. I did go in with a fine scalpel blade and gently turned those sides of the, you know, the grippy bit of the valve base in, thinking that might make a bit of difference, but in manipulating and moving them I found that the basically, yeah, the metal, I think it is some metal fatigue going off, so that didn't work. So then I went back to like sort of basics. A pentode is different to a triode in that it has a, well, it has a few more grids, but the main one is the screen grid. So in a triode the problem you've got is that the electrons boil off the cathode towards the anode, and some of them bounce back, and you've also got like a sort of problem with inter-electrode capacitance, but we'll leave that one on the side there for now. Essentially the screen grid G2 is usually set at a little below anode voltage, because the electrons come off the cathode up to the anode and having a bit of a lower potential on that last grid, the screen grid. Well, it's not the last grid because there's also the suppressor grid, which we won't go into that at the moment, means that we get less inter-electrode capacitance, etc. If the screen grid G2 is too low a potential, too low a voltage, the valve isn't going to work. Basically you can sort of think of the screen grid as another control grid. Again, we won't get into the complex sort of stuff. So what I did, after having tested it the first time, I looked at the voltages with the valve pulled out, and what I noticed was that the screen grid here on pin 1 of this EF86 was very low. Now it shouldn't be very low. Basically, I'll go and show you the schematic in a minute. What they do to drop the voltage or the potential of that screen grid is to use a 1 meg resistor to drop the HT a bit. So why was that sitting at a low potential, low voltage with no current going through the valve? See our old friend, these mica molds here, that in when the valve is working decouples any sort of stray AC that we don't want to ground. If this is leaky, that will pull the voltage of this screen grid down. So what I did, I just cut off the end. They're going to be replaced anyway, and that cured the problem of the screen grid being too low. However, that didn't solve our problem. So now we need to go and look at the schematic to try and delve deeper into why this valve isn't conducting, isn't working, and we need to sort of put the valve base issue on one side for now. Right, hopefully you can see what bits we need. I'll just try and adjust you a bit. There. As normal with valve or most schematics, you've got your higher voltage here at the top, ground down the bottom, 0 volts down the bottom. So a signal comes in from the left hand side, and we've got the various inputs, and this goes through this switch. So let's just take the radio signal for instance. That comes in, let's say the switch is here, that goes into our first EF86. Now I don't know if I mentioned it in the past, this circuit isn't the best. We've got a very low amplitude signal. Magnetic pickup or magnetic cartridge only kick out about 10 millivolts, and so this network here, these resistors here, attenuate that signal. It then goes through this EF86, our first gain stage, which has I'm not quite sure how much gain, but it has a hell of a lot of gain obviously. Part of the signal here comes off the anode and is fed back through these series of resistors, capacitors. That's just local feedback to try and shape the sort of response of the input signal. And then as you can see, here's our old friend, the 1 meg resistor, dropping the potential, the voltage, to our first V1 screen grid. Everything's so good so far. If this capacitor here, which is those big blue ones, the mica molds, if that is leaking, any voltage that the screen grid sees will be lowered, because we've got a big amount of voltage being, you know, dropped to earth, let's call it for now. After that comes out there and the feedback circuit and all that, it goes through our volume potentiometer, a volume pot, which is a 1 mega ohm log resistor, sorry, potentiometer, hell of a lot to think about. Which goes into our V2. So hopefully it's got more amplitude now after being through that attenuation, etc. However, if we look, the control grid G1 hasn't got a grid leak resistor. Instead, they are relying on this 1 meg pot. They're relying on the control grid, obviously having good contact with a wiper and everything, to set the control grid at 0 potential. To complicate things, we've also got this switch here And essentially what it does, if you want, back in the day stereo wasn't a thing. Most people would just have one amplifier, a mono amplifier, and so what they've done, they've put a provision here. If you want to run this stereo preamplifier in mono, then you would ground the grid of one of the channels of this V2 here, and that essentially is what S2 switch 2 does. And now we get to the nub of the problem. Our valve V2 that isn't working in the workshop there, if that hasn't got proper contact, or you know, a proper reference to ground of that control grid, then the damn thing isn't going to work properly, is it? Because basically it has no bias, and so everything won't work. So when I powered it up earlier, watch the cathode voltage rise, and then it suddenly went off. Could be a potential fault there, needs looking at. And then basically I'll just finish up going into a quick sort of signal path. Signal goes into V1, into V2, and then we've got more attenuation here. And basically this here is our tone circuit. It's just a very passive tone control circuit. So our amplitude of our signal that has gone through a couple of stages of gain also get attenuated here and here. Not best practice. Usually in preamplifiers you would have like a cathode follower after this stage, which doesn't have any gain, but at least it can drive the power amplifier properly. As it is, not good. So this gives us a potential few places to look at for a fault. The potentiometer here, the pot here, the volume pot, and various other things. So I'm going to go and look at that now, and then I'll update you later, because this is taking quite a long time to nail why this one valve of the circuit isn't working. There's different ways of going about getting something like this back to running. You can just go in, shotgun take out all the capacitors that you think, well, we've got a pretty good idea on knackered, and then go from there. I like to try and, with this, I've tried to do it a little bit differently, in that trying to find out what's right first before like just going in and hacking things about. The other thing that makes this job a lot more complicated is its construction, which I mentioned is really good. However, all the leads going to valve bases and things like that are mechanically fixed before soldering, so all the leads are bent over. So there is absolutely no way that I can go in there and take them out without damaging the valve bases. Here we are, another day trying to get this Stearns preamplifier working. I've changed the valve base on this valve here. This was the one that we were getting no cathode current, you know, the valve wasn't conducting basically. And I also changed the capacitor that decouples the screen grid for a new one. So now we have 273 volts on the screen grid going to the anode. 273. Should be lower than that. All the other ones show about 130 or lower on the screen grid, so all is not well. And then if we come over here to the cathode, we've got 0.6 of a volt, 600 millivolts, and if we go to the control grid, we've got 1.4 volts. Yeah, so I mean the difference between that, what's that, 1.4, 1.6, 0.8, it's not firing on all 4 cylinders. Why? And then the other one, the one it's sort of brethren over here, I don't know which is left and right, is now reading bugger all, but I'll get to that in a minute. So this preamplifier continues to be stubborn and a pain in the arse. If I just point out, this is the control grid. This wire comes from here along over to this pot. So if I move the volume control, I'm sitting on the cathode, that goes from 0.6 to bugger all. Let's see what happens to the control grid. That goes from bugger all to 1.5 volts. Definitely something wrong here. Let's just see if it does the same thing over on the other one. So we've got nothing on the cathode adjusting it, and we're getting still nothing. I think I know why that is. And on the control grid, okay, we've got 163 volts, which then goes to nothing. So as you can see, we've got a whole box of little demons in here having fun, laughing at me, sticking 2 fingers up and basically bearing their arse. Where the hell do we go from here? Well, systematically we've got to go through the whole damn thing. Think we're still okay over here ish, but yeah, this second section, yeah, it's just turning out to be a freaking nightmare. So obviously one thing that I haven't done so far is to test the valves themselves, but I've sort of been delaying doing that because the valve bases continue to be shite. So I mean, let's just take this. This is the one that I've changed. Steady. I mean this one, yeah, if a gnat farted, that would dislodge it. I mean, it's just, finally I'm getting somewhere. Go on, squeak, you bugger. That's the output from the second EF86 off one channel, right channel. Just gonna muck about with some. Right, not quite sure what's going off there. Yeah, so finally we're getting somewhere, and the DC conditions are as they should be. So as you can see, there's a lot of components tacked in all over the place. So after sort of banging my head against the brick wall trying to get the DC conditions right, I tested the valves. All of them tested okay-ish, apart from these 2 here, which tested low. One of them blew the fuse on my meter, so there might be an inter-electrode short there, so not quite sure what's going off there. So we're making progress. Bit of a long video there, going into a lot of things and sort of going backwards and forwards and whatnot. I've been trying to, rather than just like replacing a load of components, obviously trying to find out why things aren't working, just to try and illustrate more about how to fault find and things of that nature. Obviously, like if I was fixing this thing on a commercial basis, I want to mucked about with half of that, but it's been illustrative as well because now I understand the circuit a lot more, and if I do encounter any issues later when I've replaced a lot of components, then I'll have more of an idea of where to look. The problem with like just going in and just shotgunning and replacing loads of capacitors and components is that while you're doing that, you could be introducing more faults. I've ordered some new valve bases. All of those I'm going to replace the whole lot basically. I was trying to put that off because, as mentioned previously, to try and replace them involves a lot of work. In the meantime, while they come, I've started on the power supply, and we're using the old back-to-back 2 low voltage transformers. So these are two 12 volt secondary transformers, and yeah, we'll make it all work. And I've also just been testing the DC supply for the heaters. Thanks very much for watching. Take care of yourselves. Ta-da for now.